So hey everyone, welcome to today's class. Now in our previous sessions, we have covered about arrays. Moving on to stacks. Now what is stack exactly? We might have heard this terminology not just in computer science, but also in our day-to-day life. Stack up the books, stack up the plates. So what is the stack exactly? Now when you stack up something, what do? You place one above the other. For example, when you stack up books, you place one book on top of another, one above the another. Same goes with the plate. So that is same how a stack is implemented even in computer science. That is how a stack is represented. Now, yeah, sorry, stack is a linear data structure, which is a non-primitive category. Comes in the category of non-primitive, but it is a linear. Similar to array, it is linear. It's going to be stored sequentially. Then stack. What is the difference between stack and an array? In array, as we have learned in the previous classes, that insertion or deletion was happening at whatever location was specific to us or whichever location that we desire. But in stack or in the further classes, then we'll be learning about queues. So there's a difference. In stack, what happens is it follows the principle of last in, first out, or first in, last out. It can be either last in, first out, or first in, last out, vice versa. So what does this last in, first out means? So basically, when see, imagine that you are piling up a book. 1, 2, 3, 4, 5. You have 5 books and you have piled it in the row of 1, 2, 3, 4, 5. Now, what will be the easiest way to remove the book 5 or book 3? The easiest
Removing
way,
it from the top.
yes, the easiest way would be replacing it from the top, because distorting it from the bottom might be hard. It might imbalance the book and all the books might fall. That affects the stability of the representation. So similarly, even in our data structures, we represent stacks in the form of sequential memory location, where the accessing or insertion or deletion happens from one side only. So it's basically like a closed container with only one opening. Okay. Now stacks, how stacks are actually implemented, you might think that there might be a separate data structure, like integers, we had separate integer, int, char, or in arrays, we used to declare it as a of 10. But in stacks, there is nothing as such. Stacks can be implemented in two ways. One, the static stack. Static stack means where the size cannot be changed further. That stack can be implemented using arrays. Then moving on to the dynamic stack. Now, what happens in dynamic stack is the problem with static stack is you cannot change or alter the size. Once you have declared the stack size, that is fixed. You cannot alter it. But there might come a situation where you need to have more space. So we go shift on to dynamic stack. So what happens in dynamic stack is you can add further based on your requirement. You can change the size of the stack. Now that is implemented using linked list. Then in arrays, we had insertion and deletion, but in stack, we don't use the terminology of insertion and deletion. We use the terminology of push and pop. Okay, so push is basically inserting the element into the stack, and pop is basically removing the element out of the stack. Now, what differentiates a stack from an array? Now, in array, you could enter from here, you could enter an element in between, or you could enter an element from either side. But in this was happening in array, but in stack you have only one opening. Now consider this to be my stack. So here there is only one opening which is on top, and in general representation, that variable which which allows us to insert or delete, we name it to be as top. Okay. So what happens is we initialize top in the beginning in the algorithm. I'll explain you the algorithm also. So just have a brief idea here. So what happens is there is an array. We declare an array, say a of 10 or a of n. Let's say it like this. Okay, let's say a of n has been declared. Now this n will contain the number of elements to be inserted into the stack. And this top will be, initially it will be initialized to -1. Why -1? Because we have learned that in array the index starts from 0. So if we initialize top to 0, it will be pointing to the first element of the array. But we don't want that. So initially what we do is we initialize top to -1 and we declare an array. General declaration of an array, be it A of 10, A of 100, depending on your requirement. So let us assume in this example, we have 1, 2, 3, 4, 5, and 6. So A of 6, here n is equals to 6. So A of 6 is being declared. So that reserves us with 6 memory locations. 6 memory locations will have their own respective indexes starting from 0 to n-1, which is 5. Now initially top is initialized to -1. Now when you start your iteration, when you start inserting an element to your first, your first will be A of 0. When you start inserting a value to A of 0, you increment the top value also. Okay, so now top was initially, now for example, this is A of 0. So you are adding, let's say you are inputting a value of 10. So 10 will be added here. Now, initially, top was -1, which was not pointing anywhere. Now, once you have added any value into the stack, you point that value to the top variable. So you increment the top value, and this time the top will also be pointing out to the first element. Okay, any doubts with this? Okay. Similarly, pop. Now what happens is here we have the final index is 5. So A of 5 till A of 5 you can add the value. So each time you input a value, you also increment the value of top. So what happens is when you input all the 6 elements, your A of 5 will also be pointing to the top variable. Here A of 5, this becomes A of 5. To this variable when you have added value to all the elements of the stack. So this value, this becomes the index is A of 5. Okay, let's just imagine what is happening. Okay, now when you input all the values in top of the stack, you also initialize the top variable to that. Okay, so your A of 5, your final index will be equated to your top. Now, when your stack is full, how do you understand when your stack is full? When your top is equals to n-1, the compiler understands, okay, all the elements have been inserted into the stack, so the stack is full. I cannot further add any more elements to the stack. Now, how do you pop it out? When before you pop it out, you need to have an idea if there is an element present or not. You need to, how can you pop an element or how can you delete an element if it's not even existing? So you need to check if the stack is containing any elements or not. If it is not containing, then you can just say the compiler, you can say the user, there is no elements present in the stack, kindly add the element, then you can perform the pop operation. Similarly, you can go, same goes for push. If your stack is full, how can you insert more elements? It's not possible. So there are two conditions. Condition 1, in order to check the push, in order to perform push operation, first you need to check if your top is equals to n-1 or not. If it is equal to n-1, then you cannot perform the insertion operation or you cannot perform the push operation. Similarly, when you're performing pop operation or the deletion operation, you need to check if your top is equals to -1 or not. Okay, if your top is equals to -1, that means there are no elements present and you cannot delete any element. Okay, so these are two primal conditions. Yeah, so this is the algorithm of push and pop. Let's analyze it line by line. So if now this is for push and this is for pop. Now what happens in step 1 is, as I said, when you are performing the push operation, you are analyzing if there is any space available or not, if there is sufficient space. So our first step is to check if the stack is having sufficient space or not. So my first statement, if top equals to max minus 1, we say we print overflow. Now in the terminologies that is used in stack is overflow and underflow. You cannot say that if your stack is full, you cannot say the stack is full. Okay, the terminology which is used is overflow. The Similarly, what happens in the tank also, right? If the water is reached to its peak, the water overflows. So there is no sufficient space for the water to add in. So if your top is equals to -1 or n minus 1, so max is basically equated to the number of elements. Now, if your top equals to max minus 1, then there is no sufficient space available. Your stack is basically filled, so you cannot add more element. If it is not, so what you do is you initialize top is equals to top plus 1. Now, reason being is when you have added the element, you need to increment the value of top. So whatever new element you add, your top value will be incremented consequently. Then as soon as you've incremented the value of top, you then add the element into the stack. So basically what is happening, try to understand virtually. Now initially top is equals to -1. Now I have added an element called 10 to this top. So top will be pointing here. Then I have added another element 20. Now this top which was pointing here will point to 20. I have incremented the value of top by 1. So top is not pointing to 10 now. Top is pointing to 20. Similarly, when I have included 30, top is again going to point to 30. So the most recent element that you add, the top will always be pointing to that. Any doubts?
No, sir.
Great.
No, sir.
Moving on to pop. Now, pop, as we said, the terminology used is underflow. Underflow means there is no element present, the stack is completely empty, and you cannot remove or cannot delete any item. So the algorithm goes, if top equals to null. Now the general representation of null is -1. If you initialize any variable, because what is -1 exactly? The 0 is having a value in arrays because 0th index, but -1 is having no such variable or no such value. That is why we either initialize any variable if you want to null or -1. It is either the same. In your programming, if you go through any such lines which says that variable is initialized to null or that variable is initialized to -1, both means the same. You might be seeing this in your aptitude or any other competitive exams. They might ask you, is there a difference if we initialize a variable to null or if we initialize a variable to -1? It's both the same. There is no difference. Okay. So once if the stack is not underflow, if there are elements, then we perform the pop operation. So what we do is we declare a temporary variable and stack of top. Obviously, your top, all the elements that you have been popped out will be the one on top, right? Because it works in the principle of first in, last out. So the most recent, yes.
Sorry to interrupt. So what is VAL at
Sorry?
step 2? Step 2, there is something called set VAL.
Yeah, that is a temporary variable value.
Okay.
Okay. Now this temporary variable, as we discussed in our deletion operation in array, when we delete an element or we replace an element, that value is actually lost. There is no way of getting it back. So what we do is whenever we perform any deletion, any sort of deletion, we store that value into a specific variable. Okay. Now this val in step 2 is basically that variable that is going to store the element which has been deleted now. So your stack of top, the first element, let us say, let's finish this stack, 40, 50, 60. Now, obviously, insertion and deletion will happen at this end only. It cannot happen in between. Now, your top is positioning to A of 5, which is 60. So, stack of top, which is value of 60, this 60 will be stored in val. So, val is equals to 60. Okay. Then what you do is top -1. So once you have stored that value, your top was pointing here. Then you're coming a step back because that value has been erased. So your top will now point to 50. Understood? So this is the basic operation of push and pop that you perform on a stack. There are also other operations called as seek. Now what the seek does is it returns the topmost element. Now for example, in this stack, the topmost element is 60. So if you are a third person who have no idea what are the elements present in top, but you still want on the stack, but you still want the topmost element. So what you can do is you can perform the seek operation, which will return you the topmost value. Okay, the element which is on top, that is a seek operation. Next is size. Is size will give you the total number of elements present. If in this case it is 6, there are 6 elements which are present. Then there are basic other array operations that can also be. Basically, stack is nothing but an array.
Yeah.
Okay, now why do we need to learn about stacks, or how stacks are helpful to us? So let us learn about applications of stack. A stack can be used for evaluation of expressions. Now, do you guys have any idea about postfix and infix expressions? So when we evaluate infix and postfix expressions, right, we push them in the stack so that this all those expressions, all those variables are being stored in different elements of stack, different levels or different cells of stack, so that evaluation becomes easier. So evaluation, whenever we evaluate any expression, stacks are needed. Then we talk about backtracking. See, what does backtracking mean? When you proceed in a program and you have entered a dead end, you have reached a dead end. So what do you think? Should you restart it again? So when you restart again, it's kind of a time consuming and wastage of resources. So what we do in backtracking is we retrace our previous step, and we then conclude at which step have I gone wrong. For example, if now if you're traversing from here, you have traversed here. Now you have two decisions to make, two logical arithmetical decisions. Now if you have taken this and you are reaching here, which is a dead end, so you need not start from here again. You need not start from here again. So what you can do is you can come back, again come back to the initial position where you had actually taken the decision, then use an alternative path. That is the concept of backtracking. Then systematic memory management. Unlike array, where insertion or deletion can happen at any location, which was quite confusing because when you declare an array and someone else is performing an operation and a third person is coming and reading it, he might be confused. So the third person will start thinking, where was the insertion done? Where was the deletion done? But when it comes to stacks, there is only one direction in which the deletion or insertion can happen. So yes, it is really easy to analyze the elements and the operations that can be performed on stacks. Now talking about the advantages, now stacks, right, as the basis, the entire model of stack is relied on the fact that it works on the principle of last in, first out, or first in, last out. So you have an idea in mind. Okay, so you're not distorting. Similar example for the books. If you start taking, suppose all the books, example 1, 2, 3, 4, 5, 6 books were piled up. If you start taking the bottommost book, book 1, which was at the bottom, there's a high chances that book on top will fall. Then we have it allows to control and handle memory allocation and deallocation. Allocation and deallocation is easier. It helps to automatically clean up the objects. Next, talking about disadvantages. Yes, limited memory is one such disadvantage. Reason being, when we use anything with stack, right, the memory size is fixed. Static memory location is the disadvantage when we are actually building a dynamic program. But that has overcome using linked list. But in order to understand linked list, also it's kind of complicated. So a dynamic stack as a whole is a complicated topic. So that is one of the drawbacks. Random access is not possible in stacks. As I said, any element, any operation happening always on top of the stack. There is no other alternative, right? So all those operations, be it insertion, be it deletion, be it seeking, be it pop, It's all happening on top. So if you want to have, if you want to check a random value in stack, that is not possible. Okay. Any doubts?
No, sir.
So with this,
No,
we conclude our session of stacks.